In the modern landscape of scientific inquiry, there exists a fundamental tension between predictive power and truth-seeking. While mainstream science often prioritizes the development of models that are empirically successful and statistically reliable, some thinkers maintain that this is not enough. To truly understand the universe, they argue, science must not settle for approximations or bounded predictions. It must strive for truth. This video defends that perspective and argues for its philosophical coherence, ethical necessity, and potential to guide the evolution of scientific thought. The dominant model of science today is utilitarian in nature. Theories are constructed to explain observable data and make predictions, which are then tested against experiments. If a theory consistently produces accurate predictions within acceptable margins of error, it is regarded as successful. This is the heart of effective field theory, EFT, a framework in modern physics that constructs models valid within specific energy scales while systematically excluding high-energy effects. EFTs have been remarkably effective. For instance, quantum electrodynamics, QED, predicts the magnetic moment of the electron to within 12 decimal places of experimental results. Yet this precision, impressive as it is, does not equate to truth. These models are not final descriptions of reality. They are tools, methods of organizing information that work within given constraints. The practice of quantifying uncertainty does not remove that uncertainty. It merely formalizes it. Thus, predictive accuracy, no matter how refined, remains an epistemic approximation, not an ontological revelation. The view that science should aim not merely for predictive power, but for true understanding, is grounded in a rich philosophical tradition. It echoes Einstein's realism, which held that science must uncover the underlying mechanisms of the universe, not just model its appearances. Descartes' rationalism, which sought knowledge founded on certainty, not probability. Karl Popper's critical rationalism, which emphasized the need for falsifiability and continuous skepticism toward accepted theories. Thomas Kuhn's insights about paradigms in scientific revolutions, showing how science often clings to models until pushed to abandon them. From this philosophical standpoint, settling for models that work well enough is not just intellectually lazy, it is ethically limiting. Science must be an engine for truth, not merely a factory for forecasts. Empirical science by its nature is constrained. It operates within finite contexts, uses imperfect instruments, and interprets data through the lens of human-constructed models. All empirical evidence is, in a sense, theory-laden. Observations depend on prior assumptions about what is being measured and how. When we say a theory matches data within error bounds, we are not saying it is true. We are saying it has not yet failed within the limits we've defined. This opens the door to information bias. If a model is constructed under certain assumptions, and its success is judged relative to those same assumptions, we risk circular validation. While error margins offer a measure of confidence, they cannot eliminate the underlying epistemic fragility. The term epistemic trust refers to the justified belief that a method, model, or framework is reliable, based on its track record. It is not blind faith, but a conditional endorsement grounded in practical success. However, this trust must be tempered with philosophical humility. A model that works today may fail tomorrow, as history has shown repeatedly, from Newtonian mechanics to the Ptolemaic system. The danger lies in mistaking this instrumental reliability for ultimate truth. Scientific models should not be epistemic endpoints. They should be viewed as provisional, fallible steps in a longer journey toward understanding. To equate practical reliability with truth is to confuse the map with the territory. Despite the current dominance of empiricism and pragmatism, the pursuit of true, unified knowledge remains an essential ideal. It fuels the most profound advances in science. Einstein did not settle for Newtonian mechanics because it worked well enough. He sought deeper consistency. Likewise, quantum mechanics emerged not because classical models failed every time, but because they failed fundamentally in certain domains. This idealistic demand for coherence and completeness has historically led to revolutions in thought. To abandon it in favor of statistical comfort is to constrain the future of discovery. So, is the view that science must seek truth over approximation correct? It is not only correct in a philosophical sense, it is essential. While predictive, power is indispensable for technology and practical success. It should never be confused with metaphysical truth. Science needs the tension between pragmatism and idealism. The former builds, the latter directs. My view, that we should not settle for predictive models, but pursue unified, principled knowledge, is more than correct. It is vital. Without it, science risks becoming a tool of convenience rather than a path to understanding.